Hi, my name is Allie Legra, and I can just smell that this is going to be a fun gizmo. Have you ever woken up to the smell of breakfast cooking on a Saturday morning? How do you think the smell travels from the kitchen to your bedroom? In the Diffusion gizmo, you can explore the motion of particles as they bounce around from one side of a room to another. This gizmo can also be used to learn about how odors travel, how fluids move through gaps, and the thermodynamics of gases. When I went to the farmer's market with a friend last weekend, we both found great-smelling flowers at different booths. After taking in a deep breath, we asked the other to smell our flower choice. How long do you think it will take for us to smell the other scent? Let's start with particle X in area A and particle Y in area B, and see how long it will take to reach 50% of X and Y in either area. First, we need to set the wall to 0% because there were no barricades at our farmer's market. Then we need to set our X and Y particles to 100 because when we showed our flowers, we had a full plant. Our temperature is set to 300 K because it was a hot one that day. Our particle size is set to 1 AMU. Let's click play and see what happens. What have you started to notice? How long do you think it will take for each of us to smell the other's scent? Let's look at the data found on the Table tab, which shows us the percentage of X in area A per second and the percentage of Y in area B. Doesn't seem like our smells are traveling all that quickly. The Bar Chart tab is great for analyzing the data, and the Graph tab gives a great visual of the diffusion process and how the percent of particles in area A and B change over time. Every gizmo has a set of lesson materials. This gizmo has some excellent real-world applications in its lesson materials. The teacher guide has a great pre-gizmo activity that I like to use with my students. I stand in one corner of the room and spray an air freshener into the air. Ask students to raise their hands as soon as they smell the scent. As they raise their hands, the progress of the spray particles through the room can be traced. Ask your students why the air freshener spreads through the room. Does the air freshener fill the whole room, or does it stay in just one part? Then I demonstrate diffusion by adding a drop of food coloring to a glass of water. After 5 minutes or so, the color will be evenly spread throughout the water. Activity A is one of my favorite activities for showing students the relationship between temperature and diffusion. It allows students to come to the conclusion that temperature affects particle motion and minimally diffusion, but that diffusion heavily depends on the random movements and collisions of particles. To follow up activity A, I like to have the students use activity B as an open inquiry lesson in which the students select a variable to test while designing their own investigation with a hypothesis, procedure, and analysis of results. Now there is a reason to stop and smell the roses. Check out our related gizmos: osmosis, Boyle's law and Charles's law, and temperature and particle motion. It's time for me to diffuse away and say bye for now, Gizmos fans.